Hi everyone, this is Jay, and in this video we are going to learn about flow control. So, why we need flow control? Suppose a person is typing and sending message very quickly, but the one who is receiving is kinda slow. So he's not getting what the sender is trying to say, and you know what happens. Same concept applies to computer network. If one computer is sending data, let's say at 10 Mbps, but the another is able to receive data at only 2 Mbps, then there will be loss of data at the receiver side. To prevent that loss, we need to implement the flow control. The flow control is categorized into two types, for noiseless channel and for noisy channel. There are two protocols in noiseless channel. The one is simplest and another is stop and wait. And for noisy, it is having stop and wait ARQ and sliding window. Let's discuss the noiseless first. In noiseless channel, we are assuming two things. First is there is no packet or acknowledgement lost. And the second is no noise is added on the packet that are being sent. Let's see the first protocol in the noiseless channel, that is simplest protocol. In simplest protocol, the sender is sending data at super fast speed, and the receiver is also able to receive data and process data at that speed. So it can be seen that the packet 0, 1 and 2 are sent by the sender, and all of those packets will be received by the receiver without any problem. But now, what if the receiver is slower than the sender? Actually, that is the case in stop and wait. In stop and wait protocol, the sender is super fast, but the receiver is slow. That means sender can't send data directly. Instead, after sending first packet 0, it has to wait for the acknowledgement to send the next packet 1. The protocol that we have discussed are for noiseless channel, but in real life, the channel will always be noisy. When channel is noisy, there are higher chances of packet loss or acknowledgement loss. Let's see what happens when a packet gets lost. Let's consider two devices A and B are following stop and wait protocol. So after sending packet, the device A is waiting for the acknowledgement from B. Now because of the noisy channel, suppose packet 2 gets lost. Now because packet 2 is lost, the B will wait for the packet 2 because it has sent the acknowledgement for packet 1. And A will wait for the acknowledgement for packet 2 from B. But neither of them will get anything, and they will both be waiting for infinite time. Same problem will be there if acknowledgement gets lost. So to solve this problem, the sender will use ARQ method or ARQ timer. Let's see the ARQ in stop and wait. ARQ is fixed timer for which a sender will wait for acknowledgement from the receiver. If ACK is not received in fixed ARQ time, then the sender will send the packet again. As you can see, the device A has sent the packet 0 and it has received acknowledgement from B in fixed time. But as the packet 1 gets lost, the acknowledgement will not be received from B in fixed ARQ time. So after waiting for ARQ time, let's say after waiting for 5 seconds, device A will retransmit the packet to avoid the deadlock infinite waiting condition, and subsequent packet will be sent without any problem. So this is how flow control works.